This is Unit 7, Circles. Lesson 7.3, Circumference and Area. Please make note of both the location, the date and time that you're watching this video, and don't forget to get a parent, guardian, or teacher sign-off. Let's do a little review from our previous lesson. It says we have a diameter of a circle which is 60 inches long, and a chord of a circle which is 48 inches long. How far is it from the center of the circle? Let's draw this out here. So we're going to be talking about from the center. Let's draw the center of the circle. We're going to be talking about a diameter here, so let's draw in a diameter. We're going to be talking about a chord that is going to be from the center of the circle. So that implies, that term from the center implies two things. That implies that it's going to go through the midpoint of the chord and is perpendicular to the chord. So we need to draw the chord so that the diameter goes through the midpoint and is perpendicular. So here's our chord, which is going to be 48 centimeters long. There's our midpoint, so we're going to get hatch marks on there, and the word from the center automatically implies also a right angle. This diameter is 60 inches, which get in the habit, if there's a midpoint of something, get in the habit of breaking this down. So this is going to be 30 and 30 here, the blue is. And right here, if it's 48, that means this is going to be 24 and 24. And we're going to be asked, how far is this chord away from the center of the circle? Now, from the center is an actual segment here. I'm just going to make this in hot pink. That is the concept from the center of the circle. That little segment represents the distance of the chord to the circle center. So in a circle, distance is actually a segment. So we're going to call that our x. I'm going to pause for a moment and wait for your diagram to catch up to mine. So we're being asked to solve for the pink, and it might not be directly evident how to find the pink, but one thing I want you to keep in mind, where you have a right angle, make this little note there, where there's a right angle, you should try to make a right triangle. Where there's a right angle, you should always attempt to create a right triangle if at all possible. So let's see if it's possible to create a right triangle. Well, remember all radii are equal, so if this is 30, let's swing around the radius and connect it, then that's 30, because all radii are equal. Now look at what we have here. Behold, a right triangle. This is no longer a circle problem, it's a right triangle problem. So let's bring that right triangle right down here. That is our unknown x. What else do we know here? We know our radius is 30, so that's 30 right there. And then this other leg is 24. Our units are inches in this case, right angle. So now we're going to write our equation out for the Pythagorean theorem, which is leg squared plus leg squared equals hypo squared. I'm going to pause for a moment, let you write that down. Now we're going to circle plug chug. Leg Our one leg here is x, so it's going to be x squared, plus our other leg, which is 24 squared, equals the hypo, which is 30 squared. In this case, x will ultimately equal 30 squared minus 24 squared, and then the square root of. So we can actually now get out your calculators. Okay, so we're going to go 30 squared minus 24 squared. That equals 324, and then we square root, and that is 18. So our x here is 18 inches. So our distance, the chord, is 18 inches from the center of the circle. 18 inches. That's a recap of our previous lesson. Now let's get into today's lesson. Today's lesson might be a review for a few of you. Let's go over our vocabulary words for today. Of course, we're going to be talking about a circle. Radius is a previous word. Diameter you've known. Now we're going to talk about circumference and area and the concept called pi. So it says in the following circle we want to trace the circumference of the circle and then trace the diameter. So trace the circumference and trace the diameter in every one of these. So we're going to trace the circumference and then trace the diameter. So you should have traced each circumference, which is around the circle, and the diameter. You're going to notice that all circles have the same shape, of course, but they're just a different size in this case. Now that should start ringing a bell to your ears, because things that have the same shape but a different size defines the concept of similarity. Similarity. Same shape, different size. The technical definition of similarity, we use the acronym SCARE. SCARE stands for similar. Similarity is congruent angles and ratios equal. That's an L, not a T. Similarity is congruent angles, ratios equal. That's the acronym SCARE. Take a moment and write that down, please. Now, I'd like you to box these words, ratios equal. Ratios equal. There's a ratio in these circles that regardless of the side of the circle, the ratios are equal because all circles are automatically similar. The little similarity sign. It is a very special ratio in which you divide the circumference by the diameter. Okay, I'd like you to, it looks like this. Circumference divided by the diameter. Notice I'm using a capital C there. The circumference divided by the diameter. Circumference divided by the diameter. Because the triangles are similar, this ratio this ratio of circumference divided by diameter, the ratios are going to be equal. That particular ratio, since all circles are similar, this ratio will be equal for all circles, regardless of their shape, because they're the same shape but a different size. They are similar. All circles are similar. Let me emphasize one more time. That implies there's specific ratios which are going to be equal for all circles. Whether we're talking about the circumference and diameter of a circular atom or the circumference and diameter of a circular planet, they're going to be equal. There's a name for that ratio. This particular ratio, which is consistent to all circles. So we're going to do this. Circumference, again, trace it, that's C, and diameter, we're going to use D. Circumference divided by a diameter for all circles is the exact same number, and that number we call pi. Now it says, using algebra, isolate the circumference, because there's another equation you need to be familiar with. So let's do that. Circumference divided by diameter equals the constant number pi. Now I'd like you to circle the circle circumference. We're going to isolate it, which means we're going to use algebra to get C by itself. Now here we have circumference divided by diameter, and we want to get rid of the diameter, so we're going to multiply both sides by the diameter. Cross it out. So circumference is going to equal, always, the circumference of a circle will always equal the diameter times pi because of that ratio. Another way, which is obviously used on, or more commonly used on SATs, the second expression for circumference, because the diameter is 2 radii, so put your 2 radii there. If we take that diameter and we make it 2 radii, another common equation for circumference would be 2 pi r. Because 2 radii make up a diameter. 2 pi r is what's commonly cited on SATs. In this geometry class, we're going to use the more simplistic version of circumference, which is simply circumference equals d pi. Very important rule in class. If I ask you for the circumference of a circle and you give me d pi, that's not the equation for circumference of a circle. An equation has 2 sides with an equal sign. So if I ask you for the equation for the circumference of a circle, I must have 2 sides, circumference equals d pi, with an equal sign, not strictly d pi. D pi is an expression, not an equation. An equation has 2 sides with an equal sign. I'm obviously emphasizing that for a reason. So that's circumference. Another common equation that you're going to use with circles is area. So shade this with me. An area of a circle is based on radius. The area, how to find the area of the circle, you first square the radius. Why do I know I square it? I'd like you to circle area. Draw a little arrow. Area is a 2-dimensional concept. And whenever something goes into 2 dimensions, you're going to have squared exponents in there somewhere. So area is a two-dimensional concept. Circumference is a one-dimensional concept. Area is a two-dimensional concept, and where you have two dimensions, you're going to have squared exponents. The area of a circle is pi r squared. That is the equation for area. I like you to write it out like this. Capital A for area of a circle equals pi r squared. So if I ask you for circumference of a circle, you give me C equals d pi. If I ask you for area of a circle, its area equals pi r squared. Do not confuse these two. And this was so critical that you don't confuse these two. Several years ago, I had two students come up with a really handy jingle. And I'm going to give credit where credit is due. Thank you to Courtney, Laura, and Megan. This is 2007. So here we are, nearly 6 years later, using this same jingle. Several students through my class have found this incredibly helpful to remember both circumference and area and not to mix them up. So first off, let me just spell out the equation. It says C d pi I C d pi. Where you see C, I like you to put C. D pi. Put a D and a pi. I C d pi. So on the right-hand side, we're going to go circumference equals diameter times pi. C, d pi, I C d pi. And for area, we're going to go like this, apple pie. So we're going to go apple pie is really, really good. The way we're going to remember really, really is there's two R's here. So put two R's with a time sign, and because it's two R's with a time sign, that's going to be r squared. So apple pie is really, really good. That's for area. This is circumference, and this is area. So I'm going to sing this once, and then you're going to sing it, and if you want to get a beat with clapping, it's actually quite catchy. It goes like so. C, d pi, I C d pi. C, d pi, I C d pi. Apple pie is really, really good. Apple pie is really, really good. Try it. C, d pi, I C d pi. C, d pi, I C d pi. Apple pie is really, really good. Apple pie is really, really good. All right, I dare you to try not to think that jingle somehow down the hallways over the next week. It's terribly catchy. I hope it is. Now we're going to do some problems together, and first I need to introduce you to the pi key on your calculators. So take a look at your calculator. We're going to be talking about working with pi and without pi, in other words, a decimal version. So it's important you're able to find the pi key on your calculator. If you have the TI 30XA, like I recommend, you'll actually see a key with the pi symbol right there. When you push it, you're going to get the decimal 3.14, and it's going to give you a full screen going on and on. In your TI 83 and 84 calculators, you first have to hit the second function button, and then you hit this button on the far right side, and then you'll get the pi key using the second function. Again, you get 3.14 and on and on. When we do the decimal version, if you don't have a pi key, you're welcome just to use 3.14 as your input. Now, there's two ways that we're going to do this. Let's look at our instructions. It says, given a diameter, we're going to find both the circumference and the area of a circle, of the following circles. We're going to express our with pi left in, with the pi key, and without pi, that's multiplying out the decimal form. So let's do I'm going to do the first two, and then you're going to do the last one yourself. So the first two, the diameter is 10 meters. We're given units. You must keep units, which implies our radius is 5 meters. And then our radius squared is going to be 5 squared, so it's 25 meters squared, because we square it. So here, circumference equals d pi, c equals d pi, and area equals pi r squared. So in this case, the circumference is d, which is 10 pi meters. Guess what? You're done. 10 pi meters is an appropriate expression to use for the circumference here. That's called with pi. Another way you could express it, if you fold pi in, see, my calculator does have a pi key, so I'm going to go 10 times that pi key. That gives me my pi equals, we're going to take it to the tenths place, 31.4. So 31.4 meters. Both are correct answers. That would be the circumference of this circle. Area is pi r squared. But we already have the r squared. It's right there. Times pi, we can write it like this. Area equals 25 pi meters squared. Guess what? We're done. That's perfectly fine. That expresses the area of this circle. Or, if you do the decimal version, we're going to do 25 times pi, so 25 times the pi key equals, we get 78.5. And my units are meters squared here. Let's do the next one. In this case, our diameter is 15 meters. Our radius would be half of 15, which is 7.5 meters. And then when we square that, we're going to get 56.25 meters squared. Now our circumference, again, is d pi, so it's d pi. So the circumference we can express as 15 pi meters. You're done. That's one way to do it. Or get the decimal version. 15 times pi is 47.1 meters. Go ahead and write that down. The area is pi r squared, and we already have our r squared is 56.25. So our first area we can express as 56.25 pi meters squared. That's the area of the circle. Or we get the decimal version, 56.25 times our pi. We get 176.7. Don't forget the units, meters squared. I'm going to give you 2 minutes. I'd like you to do that last circle on your own. Go. 2 minutes, do this circle on your own. Okay, let's see how you did. So here our diameter would be 15. So we, 6 this time. So we have 6 meters, and that means our radius would be 3 meters. Our radius squared would therefore be 9 meters squared. Our circumference is d pi, so we could use diameter. 6 pi meters would be just fine. Or we do 6 times pi is 18.8 meters. Area would be r squared, which is 9 pi meters squared. Or we could do 9 times pi, which is 28.3 meters squared. Check your work. Okay, so that's the basics of finding both circumference and area. Now there's a lot you can do with these, a lot of practical applications. We're going to do 2 problems together here. Okay, it says if a wheel, let's finger track and read. If a wheel is 24 inches in diameter, how many revolutions will it take to travel 100 feet? Okay, so first we're going to highlight, underline. So we have a wheel. It's 24 inches in diameter. How many revolutions will it take to travel 100 feet? When we're dealing with real-life first word problems, the most critical element is to watch out for your units and notice if you have a discrepancy in units, which we do. Whenever you see units, when I mean by units, I mean things like this: centimeters and meters, inches, feet, feet, kilometers, and the like. Those are units. So get in the habit of just boxing units right away, and you're going to notice here that there is a discrepancy in units. So we have a wheel that's 24 inches in diameter. How many revolutions? Revolution is the turning of a wheel. Will it take to travel 100 feet? So let's draw a scenario here. So visualize 100 feet. So we have a length of a sidewalk, which is 100 feet in length. And we have a wheel. Let's say it's a bicycle wheel here. Here's a gallant attempt at drawing a bicycle of some sort. There's that, and there's some sort of crossbar in there. Pretend that's a bicycle. Okay, there's your bike. Here's your spokes. Now, well, you have a bicycle, and we're being asked how many revolutions. So revolutions would be the turn of a wheel. How many revolutions? See, I'm drawing revolutions of the wheel. You should, as you draw this, you should see that revolutions is code for circumference. A revolution is code for circumference. So I'm being basically asked how many circumferences make 100 feet. Before we can deal with anything else, we have to convert units before you crunch numbers. Convert before you crunch. Convert before you crunch. Say it out loud. Convert before you crunch. So we already have 24 inches here. A diameter that is 24 inches. So we're going to take this into inches. So we're going to do 100 times 12, and that gives us 1,200 inches. Now revolutions means circumference, so we need to find the circumference here. Let's write this out. Circumference equals d pi. Equations, 2 sides with an equal sign. Our circumference equals 24 inches pi. Now, if I only asked you to find the circumference, you can leave it in pi form, but because we're going to be asking how many circumferences fit into that 1,200 inches, we need to take that to a decimal. So we're going to do that here by going 24 times pi and rounding to the tenths place, and we get 75.4. So in this case, one turn of the wheel, which is equivalent to our circumference, is going to be 75.4 inches gained. One turn of a wheel. So every time that wheel turns, it's going to travel 75.4 inches. Wheel turns, travels 75.4 inches. So your goal is to figure out how many turns of the wheel will it take to go 1,200 inches. That's a division concept, of course. So we're going to go 1,200 inches divided by our circumference, which is 75.4 inches. I'm going to pause and let you get all that written down. So we have here 1,200 inches divided by 75.4 inches, and it's 15.9, which means we get approximately 16 revolutions here. 16 revolutions, 16 turns of the wheel will travel 1,200 inches, what gives us 100 feet. So we did highlight, draw, label, list. We asked ourselves, what can we do? I'd like you to follow this same list. Finger track, read, highlight, underline, draw, label, list, cross out, squeeze the sponge. I'd like you to take a shot at this problem on your own. I'm going to set the timer again for 2 minutes. You take a shot and then we'll go over it yourself. 2 minutes. Go. All right, let's check it out. It says a rose garden consists of 2 concentric circles with the central circle filled with roses and the outer circle creating a pathway around the garden. If the inner circle has a diameter of 10 feet and the outer circle a diameter of 18 feet, what is the area of the pathway? Okay, so let's draw. First off, we have 2 concentric circles, 2 of them. So there's the outer circle, There's an inner circle. Cross stuff out as we do it, so 2 concentric circles. The inner circle is filled with roses, so we have roses here. That's my attempt at drawing roses. It's not very good, but you get the idea here. Got roses going on here. Okay, so we have roses on the inside. And it says that around it, the outer circle creates a pathway, if you will. I'm going to do that in green. So we have a pathway around the rose garden. We're given 2 measurements. We're given the diameter of both these circles. So we have the diameter of the inner circle, which is 10 feet. So this is 10 feet. And then we're given the diameter of the outer circle from here to here, and that is 18 feet. We're asked to find the area. Now, immediately, you should have written out the equation for area, which is area equals pi r squared. Apple pie is really, really good. Put parentheses around that. So we're asked to find the area of the green. Look really carefully. What you have here is a donut scenario. If we find the area of the larger outer circle, and then we found the area of this inner circle, we find those 2 areas, then you see if we take away that inner circle, we're going to be left with that outer edge or pathway. So we have to find the 2 areas. We have to find the area of the outer, where the diameter, d equals 18 feet. And we're going to subtract the area of the inner circle, where the diameter equals 10 feet. Remember, it's an area concept, so let's write the area equation. Area equals pi r squared. This is area equals pi r squared. So here, let's find out our equations. We have area equals pi. Watch out there. Our r is not 18, it's 9. So it's 9 squared minus pi. And here our radius is 5. So we're doing 5 squared. So our concentric area here is we have to subtract these 2. So we have 81 pi minus 25 pi. And this is the same as if we were to have 81x minus 25x. It would follow the same rule. You simply subtract those 2. You're going to end up with 56. So this is going to equal the area that we want is 56 pi feet squared. And if you want that in decimal version, it's 56 times pi, and we get 175.9. 175.9 feet squared.